Hello everyone. Welcome to our 8th lecture of fluid mechanics and hydraulic machines. The subject is offered in the degree engineering and mechanical engineering and also in the civil engineering for semester. Today we are going to start our new topic, that is the YouTube manometers. If we talk about our previous session, that means lecture number 7th, in that lecture we have discussed the classification of pressure measuring instrument. So let's start further. This was all about our classification which we had discussed in previous session. In today's session we'll see about the piezometer and the YouTube manometer. Okay, so let's start from the piezometer and what is the YouTube manometer. So this one is also the principle of manometer, which is already discussed in our previous session, and today's topic, that is our piezometer. So piezometer is nothing but a simple manometer which consists glass tube. Over here you can see that there is one glass tube, that means a transparent glass tube or a plastic tube which is transparent, and having one of its end is connected to the point where we need to measure the pressure, like this in this diagram, point A, and the other end of this piezometer which is remains open to the atmosphere. Okay, so the height of a liquid in a piezometer gives the pressure head. You can see over here the height of a liquid, which is H, in this piezometer, that gives us the pressure intensity. Okay, and this pressure intensity, which is the value at a point A, and this value that equals to PA, that equals to rho GH divided by, sorry, rho GH, and this one is your pressure at a point A. In this equation, the rho, which is the density of this flowing fluid which is flows throughout this pipeline, G, that is our gravitational acceleration, and H, that is the rays of a liquid in your piezometric tube. Okay, so simple, the SI unit of this pressure, which is in Newton per meter square. So this one is our piezometer. Okay, so we need to remember one thing, that in our piezometer the rays of a liquid which is same as the flowing fluid, that means that fluid which is flowing in this pipeline, that fluid we are using in our piezometric fluid. Okay, so I hope you understand about this piezometer. And our next topic, that is the YouTube manometer. Okay, so what is YouTube manometer? So let's start. It is consists of a glass tube like this, and which is in the bent in a U shape. That's why it is called a YouTube manometer. A YouTube manometer which is in U shape, and in this YouTube manometer, one end which is connected to the pipe where we need to measure the pressure, again like our piezometer tube, and the another end of this YouTube manometer which is open in atmosphere, as shown in these two figures. The YouTube manometer, which contains mercury, over here you can see that there is a dark portion in this YouTube manometer which is a mercury, that is the heavier liquid, or we can say as the whose specific gravity is greater than the specific gravity of liquid whose pressure is to be measured. Like if we say the specific gravity of this liquid, that is SL, which is less than the specific gravity of mercury. Mercury, that means this mercury, and the specific gravity liquid which is flowing through this pipe. So always in YouTube manometer we need to take care of the higher specific gravity of liquid, like a mercury, which is non-mixable with this our fluid which is flowing through the pipe. So these are the two types of a YouTube manometer. In that first one, which is for a gauge pressure, that means for a positive pressure which is always above to the atmospheric pressure, and the second type of YouTube manometer which is our vacuum pressure. That means if you want to find out the pressure, this one is our PATM, as we already discussed about this pressure. This one is our P absolute line, that means a zero vacuum. P absolute line, this one is our P atmospheric line. So if you want to measure the pressure above the atmosphere over here, like this point A, so this one is this much higher than the atmospheric pressure. At that time we need to find out this pressure with the help of this pressure gauge, that means our positive pressure gauge. And if you want to find the pressure which is below the atmospheric pressure or the vacuum pressure, at that time this one is your vacuum pressure, okay, which is below the PATM line. Okay, so there is mainly two type of pressures which we are going to find with reference to atmospheric pressure line. Okay, so let's start from the very first pressure gauge, which is our gauge pressure and the simple YouTube manometer or gauge pressure. In this figure we can see that the H1, which is the height of fluid or height of a liquid above the datum line. Datum line, that means this AA section which shows the datum line. And the meaning of this datum line, that is, as we know that as per our Pascal's law, the pressure intensity at a horizontal level which is always same. So in this horizontal level line, the pressure intensity is same. You can see that the change in two fluids over here in the left limb, that is this passing your line AA from this line. So the pressure intensity from this horizontal line which is always same. Okay, so change in a pressure, you can find out the change in a pressure from the above the datum line. Okay, so H1, that is the height of your liquid above the datum line. Likewise your H2, that is again the height of a heavy liquid. Over here you can see that heavy liquid, that means our mercury. And in the left limb, which is our original liquid, whose pressure we are going to find. Okay, so in the right limb there is a S2, which is again the dimension of H2 from the datum line. S1, that is the specific gravity of liquid, that means this one, that is S1. And the rho 1, that is the density of that liquid. Likewise your S2 over here, that is S2, and over here which is rho 2. So S2, that is the specific gravity of heavy liquid, this one is S2, and the rho, which is the density of our heavy liquid. Okay, so there is a mainly three nomenclature in this diagram. First one is height, that is H1 and H2, H1 and H2. Second one, that is S1, that is specific gravity of a flowing fluid, and the S2, which is specific gravity of heavy liquid. Similarly, the density rho 1, which is density of this light liquid, and the rho 2, which is density of heavy liquid. So let's start the derivation or the how to find the pressure intensity at a point B. Over here we are going to find the pressure at a point B. So as per the Pascal's law, the pressure above this datum line AA, which is a differ in this two limb. So let's find out the pressure intensity in a left limb, that is the first one, the pressure which is applied in this pipe, that is P pressure, which we are going to find in this pipe, that is the P, or you can say as the PB, which is pressure, that is the pressure in a pipe B, plus this much height above the datum level which are having the same fluid. You can see that H1, which is the same fluid. So this one is again our pressure head, so that the value of pressure head above the datum line, that is rho GH, and the rho, the density of this liquid, that is rho 1, G, that is gravitational force, and height, that is H1. So simply we need to remember the equation, that is every time we are going to apply this equation, that equals to rho GH, that equals to rho GH. And the rho for this limb, we are talking about this left limb. Okay, so for this left limb density, that is rho 1, over here we are already discussed density, that is rho 1 into G, into H1. Likewise, for the right limb, this is component or a second component for this right limb, the pressure above the datum line AA in a right limb, that is again rho gh. And what is the value of rho over here? The heavy liquid, that is rho 2 g, and h, which is the h2 height in this right limb. So by equating these two pressure above this datum line AA, so let's equate these two pressures or these two equations. This one is our equation number 1 and this one is our equation number 2. So by equating these two equations, first one is P plus into bracket rho 1 g h1, that equals to rho 2 into g into h2. So we are going to find the value of pressure and this pipe at this point P. So take a point P in the left side and the rest of the component of equation to the right side. So in this equation, that is rho 2 g h2 over here, and this rho 1 g h1, which is goes to left side, which is from left side to right side. So this rho 1 g h1 to the right side, so it will be your negative sign, minus rho 1 g h1. So this value is shows us the pressure intensity at a point B. So in this equation, we need to put all the values of rho 2, rho 1, G, H2 and H1. So by this equation, you can find the pressure intensity in this pipeline. So I hope you understand about the gauge pressure. Okay, there is a simple two steps are there. In the first step, we need to equate two equations. Always equate two equations above this datum line. Okay, above this datum line in our first equation, that is in left limb, which is rho gh. Likewise for right limb, that is again rho gh. Put the value of rho g and h. So rho, that is rho 1 in left limb, for a right limb, that is heavy liquid, so that the density, which is rho 2, g, which is common, and h1, that is in left limb, h2, which is in right limb. So let's move on the second one, that is gauge pressure. That means in this pressure, in this manometer, there is a lower liquid over here. We can see that the lower liquid, lower pressure, that means pressure at a point B, which is less than pressure at atmospheric pressure. Over here, your simple YouTube manometer, which is open to the atmosphere. So the atmospheric pressure is applied on this open end. So the atmospheric pressure is greater than your pipe pressure. Okay. So this one is our second case. Previously we had discussed that is our first case. In this case there is a PB which is greater than your PA. That means pressure at a point B over here, which is greater than the atmospheric pressure which is applied in this section PA. Okay, so this was our first case when your PB is greater than PA. In our second case, that is PB is less than PA. Okay, so let's start our second case. These all are the same nomenclatures for this diagram. Now let's equate two limbs. So firstly, we need to identify the total components in this diagram. The first component, the pipe itself, that is the pressure. Second component, that is this much, and the third component, which is this much. So total three components are there in your simple YouTube manometer. So by equating these two limbs above this datum line AA, always remember your datum line, that will be the lowest point of your mercury level. In this diagram, there is a lowest point which is in the right limb, and in the previous diagram, the lowest level of mercury that was in left limb. So here that is your datum line. In this our present case, there is a right limb which is a lower level of mercury. Okay, so above the datum line AA, the left limb equals to right limb, so we need to equate both the limbs. So the first one is pressure itself, that means the P, plus second component this much, that is rho gh, and the density of this lighter liquid, that is rho 2, okay, that is rho 2 GH2, or you can see that over here, that is the heavier liquid, which is rho 2 GH2 plus rho 1 GH1. That means this one is your component, which is component number 3. Pipe, which is your component number first. Your second component is this. So first component, that is pipe pressure, which is P, plus second component, that is the height of H2, so take a rho GH, so rho 2 GH2. Third component, that is your H1, so this one is your rho 1 GH1, and we need to find the pressure at this diagram. So P, that equals to negative of P2 GH2 plus rho 1 GH1. This whole term will be going to your right side, and that will be your negative. Okay, so this one is your answer for this gauge pressure. Okay, so let's see some of the examples on these gauge pressures, which is asked by our examination, in our examination. So the first problem by this manometer example, problem number 1, which is the right limb of simple YouTube manometer. The right limb, this one is your right limb and this one is your left limb. So in the right limb of simple YouTube manometer containing the mercury, so it is decided that the as a heavier liquid we are having a mercury containing a mercury is open to the atmosphere, which is open to the atmosphere, while the left limb is connected to the pipe. This one is your left limb, which is connected to the pipe in which fluid of specific gravity 0.9 is flowing. So in this pipe, the fluid is flowing which are having a specific gravity, that is 0.9. The center of a pipe is 12 centimeter below the level of mercury. The center of pipe, this one is center of pipe, which is 12 centimeter below the level of mercury in a right limb. The level of mercury in a right limb is this, and which is level center of pipe, that is 12 centimeter below. Okay, so find the pressure of a fluid. This pressure in this fluid in the pipe if the difference of a mercury level in the two limb is 20 centimeters. So we are having a difference of mercury level, this level and this level, that is the difference, which is 20. We are having a difference of two mercury level, that is 20 centimeter. We need to find the pressure intensity in this pipe P. Okay, so let's start from the given data. So first one, we are having a specific gravity of liquid, that is S1, which equals to 0.9. So that the density that equals to S1 into 1000, we are already discussed this formula, that is specific gravity that equals to density of liquid divided by density of water. So if you need to find out the density of liquid, that is density of liquid, that equals to S into density of water. So this same equation which is applied in this section. So density of liquid, that equals to S, which is specific gravity, that is given into density of water, that is 1000. Okay, so the same equation we are using, your S1 into 1000, that will be your 900 kg per meter cube, which is the density of this flowing fluid. Specific gravity of mercury, that is 13.6. This term is, you need to remember always, specific gravity of mercury, that is 13.6. As per this specific gravity, we can find out the density of mercury, that is S into 1000. This S into 1000, and next term that we are having, which is the difference of mercury level, that is 20 centimeter, which is S2. We can see that our right limb, that is the value of H2. So what is the value of H1? That is in the left limb H1, that means this distance, that is your H1. This distance with is H1. So total 20 centimeter minus this 12 centimeter. So you can find out the value of H1. So by taking H1 that equals to whole 20 centimeter minus 12 centimeter, that is the 8 centimeter, and by converting this, that is in SI unit, which is 0.08 meter. So now we're having whole the dimensions of H1, H2 and rho. After finding out these all the values, we need to find the pressure intensity. So let's say the equating the both side over here, this one is our first component H1, this one is our second component, and this one is our third component, equating these two limbs above AA datum line. So in the left limb, that is pressure, so over here you can see that that is pressure plus this H1 side, so that rho 1 G H1, H1 side, the pressure head of this left limb, that is rho G H, and rho, that is rho 1 G H1, that equals to right side, that is rho 2 G H2. Okay, so simply put the all value of density and the height. Rho 1, that is 900, so put the value of 900, G, that is 9.81, H1, that is 0.08 meter, 0.08 meter, rho 2, that is 13.6 into 1000, so this will be your rho 2, that is 13.6 into 1000, G, that is 9.8, and your H2, that is 0.2 meter. Okay, so that is 0.2 meter. So simply by simplification this equation, we are having the value of this 25977 Newton per meter square. This much pressure is applied in this pipe, in this fluid. Okay, that is the value of pressure. So I hope you will understand this example. So thank you. That was all about today's lecture. For the task, you need to write down all these equations starting from this piezometer. You need to write down what about the piezometer with this equation and this 2D diagram. Next one, you need to write down what is YouTube manometer. For that first one, that is gauge pressure, write down all these equations. Next, negative gauge pressure, that is B, write down all this slide. And third one, you need to solve this example. Okay, by your own self, solve this example and submit your task to your Google Classroom. Thank you.